Hope you guys doing well. So in normal distribution, it's the first thing that we can use this normal distribution for many things. Let's say like if you do exploration in mining, and if you select certain area and you drill hole, and that's for search of ore body. So you can all, I have to do a video on that. You can do it for petroleum data on, in the projects to calculate the bell-shaped curve and the mean and the variance and the data. So what is the variance? So variance is the dispersion of data from means, so it's like sigma square is equal to summation xi minus mu square divided by n. So this is per population. N is the number of data. I is equal to 1 to n is a summation of xi minus mu whole square. So what you do in the data, if you have 10, 15, 16 set of data, so for each data you put like the 1 in xi, the first data, minus mu, the mean you calculated, square and divide by the number of data, so it gives you a variance per population. And the variance for the sample is the same, but you have to divide this by n minus 1. So sigma square is equal to, variance is equal to summation from I is equal to 1 to n xi minus mu whole square divided by n minus 1. And this is per sample. So to make the sample little bit bigger, to do the standard deviation little bit more, so this is the variance we calculate. And for the project, you can use normal distribution. In the project there is a critical path, which is the longest path in the project, and which can if you want to accelerate the project, so you can accelerate one or two activities and your project will be completed ahead of the schedule. So what we do in this, this is the project which has a 5 activities on critical path, and I have calculated the beta from beta distribution using optimistic time 4 into most likely time plus pessimistic time divided by 6. For each activity I have calculated expected duration. So for the first activity is 7, the second activity is 13, the third one is 8, fourth is 14, and this is 18 days. So the total expected duration of the project was 60 days, and you can take it, this is the mean expected duration of the project, earlier expected, the earliest completion of the project 60 days. And when you do the latest calculation from the back side, this is an example. So let's say there is a 10 days slack, and the latest completion date of the project will be 10 days more, so it will be completed in 70 days. 70 days. So here is what you do for the normal distribution. You have to calculate the variance of each activity. Here I did V1 for the first activity, V2 for the second activity, V3 for the third activity, and V4 for the fourth activity, and V5 for the fourth activity. So this I calculate variance for each activity. And then when you do the normal distribution, so you have to calculate all the variance and sum it, do the summation of all variance V1 plus V2 plus V3 plus V4 plus V5. So I calculated all this variance, which is 6.35. Did you understand so far? Normal distribution is a little bit. You know what? This is normal distribution we use for the project completion date to represent this on the bell-shaped curve and give the probability of chances. Probability is a chance, 50-50, 40-50. So these are the 5 activities on the critical path. And first, for each activity, in the last video I told you, you're gonna do the beta. It's a beta distribution. Optimistic time plus 4 multiplied by most likely time plus the optimistic time divided by 6. So this will give you expected duration, or yeah, the mean of the activity. So then you have to add all these, and this will give you total expected duration of the project, which we call in our project management earliest finish. 70 days is the latest finish from the backside. And then I calculated variance for each activity by using the variance formula is like uh, T I took from here, like, so it's a pessimistic time minus optimistic time divided by 6. Whatever you get from this, you have to square it. So this is 0.69, and then I add all these and I got the variance. So when you this is in mathematics, when you want from one side, you have to square root sigma. So you will get sigma, and here you will get square root. So this is standard deviation. Sigma is equal to, so it's 2.575, or almost not 3 but 2.56, but I took 3 sometime. So this is standard deviation, which is a very good representation in the normal distribution. You can represent, yeah. It's give you a very clear idea from the mean. Three standard deviation from the right and 3 standard deviation on the left. So this I calculated, and in the next video I will draw the bell-shaped curve, and will give you an idea about the expected duration and the area between the standard deviation. So I hope you got an idea how to calculate and use normal distribution. You can use it for the critical path, the longest path in your project. You have to add all the activities and find out their expected duration, and then add up that is your earliest finish of the project and the latest finish, whatever date you have, or in between you can find any days up to 60 days, so you can find it. And then we're gonna use the z formula. Z is equal to x